It's not something that you just dump something on. It's a series of tubes.
Greetings and hello everybody, this is Chuck and welcome to episode number 2 of the Top Tech Talk Show. I'm really excited today to introduce my friend Troy Workman, who is a Cisco certified network engineer, and what he's presenting today is a little information about blockchain versus Hashgraph and why that's important. I'm really excited about this. It's some cool information. Just a little bit more techie than our usual show, but that's all right. We break it down for you, and it's going to run a little bit longer if you're watching on YouTube or the audio-only version. And that's because it's intentional. There's a lot more information than what I could squeeze in our normal time frame here. So take a listen, take a watch, share it, tell your friends about it, and click subscribe, and we really appreciate you. Thank you so much for watching the Top Tech Talk Show. So joining me today is somebody that I've known for a long time. Troy is a CCIE special network engineer for Cisco certifications that really mean he's a smart guy that knows stuff about bits and bytes. Now, that being said, what we're going to talk about is a little bit techie. I'm going to put up the big alert here that says this is the no technobabble zone. And Troy's really good at explaining things the way I can understand them. So with that being said, Troy Workman, welcome to the show.
Thank you. Appreciate that.
Troy, I've just got a couple of questions for you because we've been talking and, I wrote a book and yada, yada, whatever. It's all about blockchain and the kind of cryptos that run on a blockchain network. Now, recently, we've been reading about Hashgraph from Hedera Networks. They have what could be considered an alternative to blockchain, but it has virtually all the same features. Which is better and why, if you don't mind?
Sure. So almost everything out there is blockchain based, meaning not necessarily the first, but the first big one was Bitcoin.
Right.
But pretty much everything has followed suit. And they largely all operate the same way, that they're doing a proof of work. About to get into the technobabble.
That's
Sorry
all right. We've talked about proofs of work. I got a little graphic I usually put up on the screen, but we'll forego that for now.
So there are a lot that are not proof of work, but for example, Ethereum just switched from proof of work to proof of stake.
Right.
But a lot of them out there, Bitcoin specifically, is proof of work, which means that they claim to solve what's called Byzantine fault tolerance. That's a whole nother discussion we can get into at some other time. But basically it means everyone around the world coming to consensus, coming to an agreement about the state of something. The technologies that do that are called distributed ledger technologies, or DLTs.
Right.
Bitcoin being the first, well, not necessarily the first, but the biggest, the first big one to do that. But the way that they did it is more of a delay. It's you make a whole bunch of computers, all try to solve a math problem, and whoever solves that math problem first, you determine that they are the one who is authoritative over all of the transactions that they know about. That
so
device.
They're trying to verify that something happened on the blockchain somewhere. There was a purchase made or a transfer of coin or whatever. And the shortened version of that is, I'm smarter over here because I put more horsepower behind my processor and I'm solving this math problem faster, so that makes me more reliable. All of a sudden they get the nod and they're the ones that become the authority over the solution to that problem for the moment. Am I wrong?
Correct.
Okay, hey, wow.
That is correct. And so the algorithm that they use to determine what the math problem is and how many workers are out there working on the math problem, et cetera, et cetera. The goal is that they solve that math problem. Someone solves that math problem about every 10 minutes.
Okay.
Approximately. And after that 10 minutes, one of these computers is going to solve that math problem and it wins. So everybody says, okay, this turn he gets to decide what transactions actually get committed to the chain. And then a new math problem ensues.
And then he wins basically part of a Bitcoin or part of a crypto reward for, quote, mining that data and being able to be the authority.
Correct.
Okay.
So as a reward for doing all of the work to solve that math problem, they get, in case of Bitcoin, they get Bitcoin. In the case of others, they get the coin of the realm, if you will. Whatever.
Good. So now, if that's the blockchain, a high-level description of what's happening under the hood, what could we say that's different about the hash graph, which is Hedera? And I'm going to put up that graphic here because it's a little, overwhelming to put into your brain without a visual aid here. So just briefly describe that similar process that happens when they're trying to verify the authenticity of data in a hash graph.
Sure. So a lot of people think that a blockchain is synonymous with a distributed ledger technology. It's not. Right. Now, I don't know, 99% of them are blockchain. There are a few out there that are not blockchain. Hedera's Hashgraph is one of them.
Right.
It operates completely differently from all of the other blockchain technologies. They're not just simply coming to agreement by making everybody do a big math problem that solves no purpose.
Solves no argument, right?
Solves no purpose for humanity other than to slow down the process. And Bitcoin is slow on purpose. It has to be for it to function. So that's a consensus algorithm. Hashgraph uses a completely different mechanism for all of the different nodes on the network to come to an agreement, to come to consensus about the reality of something, like who owns a thing, for example. In Hashgraph, they call them events. That event may be a transaction. That event may be storing something. That event.
It's whatever you're putting on the Hashgraph network. There has to be a witness to that event that says, "So we saw this happen. Who agrees with me?" And that's where we're headed with the idea that it is not a distributed ledger in the old-fashioned sense, but the ledger is still maintained and it's voted upon. Am I correct?
So yes and no.
Okay.
So basically, all of the different nodes that are participating in the hash graph, each of them reaches out randomly to various other nodes who are also participating in the hash graph.
Computers, basically other computers on the network.
Exactly.
Okay.
Other computers on the network. And I tell them everything I know, and they turn around and tell me everything they know.
So you're a spy, is what you're saying. You actually spy on everything that's going on. Okay.
No, it's just, and this is called gossip. It's actually.
I love that term. It's even better than spy. The computers are gossiping at the moment, right? Okay.
Right, and this is actually a protocol called Gossip
Protocol, right.
And they are basically, I call you, I tell you everything I know, you tell me everything you know. Thanks, we both know now everything that each other knows, and I'm going to reach out to somebody else.
Cool.
And I'm going to tell them everything I know, and they're going to tell me everything they know. And
so that's distributing the ledger through gossip.
Exactly.
Okay.
And they, it's not that they have to tell everything that they know. It's what have I learned since the last time we talked? If you're going to gossip with somebody, you're going to say, hey, last time we talked,
this was going on, and the girl next door was doing that, and I caught wind of it over the fence. And so you're watching what's going on, and you report it to the neighbor that is your computer buddy on the Hashgraph network.
Exactly. So here's what happened since the last time we talked, kind of thing. We're gossiping about that.
Cool.
Well, that generates, its own traffic, sharing that information. That happens at random, intentionally. So everybody eventually learns everything that everybody else knows.
Mm-hmm.
But then you have to say, okay, so how do we know what someone knows versus what everybody else knows, and how do we come to agreement? How do we come consensus? And that's something Hedera did special called gossip about gossip.
Okay.
That's the actual term that they use. It's
right.
it's not only are we talking about what we know, but we're sharing also hash algorithms to prove what we knew when we knew it, what we learned from who we learned it from.
So how do you trust who you learned it from? Doesn't that, open up a window for fraud or some sort of other attack?
Well, and that's where that's where the term hash and hash graphs comes from, is that we're digitally signing everything.
Gotcha.
So I know because the hash proves that the person I learned it from, I then tell it to you. I'm also sharing, this is the gossip about gossip.
Right.
I'm sharing, I learned it from Bob, and here's the proof that Bob told me. So
yeah, I've seen that one where they talk about Bob and Charlene and all the people. It's A, B, C, and D on the network, and those 4 computers, they're doing some gossiping about what's been going on. But ironically, that tells me more that's going on the Hashgraph network than the crypto network inside of a blockchain, because crypto is based in math. If you understand the idea of crypto, that is a cryptographic mathematical solution that keeps things private. The hash graph isn't necessarily private, but democratic.
So we talked earlier about voting, and that's not about choosing who is the authority. That's about, do we all agree on whether something is true or not?
Okay.
And that's and you talked about witnesses, and in the hash graph protocols, one of the things is, okay, we know who initiated that event. We know who we learned it from, and we know who we told it to.
Right.
It builds this graph of who told who when. We all come to agreement of when everyone knew that a certain thing was true, or a preponderance of the evidence, if you will.
Right. Okay.
I forget the exact numbers. I believe it's 2/3 of the network knew that a certain thing was true and came to an agreement. And normally that would be done using what's called a voting protocol.
Okay.
That everybody says, yes, I knew, or no, I didn't know. And then we have to collect the votes and decide, do 2/3 of the people know that the transaction is true, and therefore we can say, yes, the transaction is true.
All right, that's actually a good point to bring up now, because once the vote happens and 2/3 agree, and when we're looking at the events, this is kind of like a city council that votes on an amendment, and it has to pass with a certain amount of people, right? So
yeah. Yes.
Now, let's take a leap forward a little bit, because when we make that happen and we see this on the Hashgraph network, is this more akin to happening over a few cycles versus what happens on the delayed time over on the Bitcoin network of a blockchain, or is this much faster, and how do things progress?
So it's way faster. And one of the reasons is we're not waiting 10 minutes or any arbitrary amount of time before we share information. We're sharing what we know as soon as we know it with two friends, and they tell two friends, and they tell two friends.
I know that commercial from the 70s or 80s, whatever.
Exactly. Until this information is spread to a preponderance of the participants in the hash graph. So I mentioned the voting protocol. Normally, a traditional voting protocol is everybody sends their votes, and then they count the votes, and then Well, in this, they do what's called virtual voting.
Right.
In that I don't have to generate a vote and send the vote to some collector of the votes, and then that collector of the votes has to do the calculations and so on and so forth. I know what you know, because we've done this whole gossip protocol. I know what you know. I know when you knew it. So I don't have to ask you what your vote is, because
you agree that you were there, you saw it happen, right?
I algorithmically know what your vote's going to be. And I have this whole hash graph, and I know what everybody's votes are going to be. So we can run a voting algorithm in memory without having to tell each other what the votes are, because we all know what the votes are going to be.
And that saves an inordinate amount of time, obviously. But does it also further the vote process in the way that, you mentioned not counting votes? How do I trust everybody that voted in this? Do I know that they're really them?
Yeah, and that goes back to the hashes in the hash graph.
So the date, time stamp, the location, I was there, I witnessed it, I saw it happen live, yada, yada. That's all recorded, and that's part of the vote, right?
Exactly. I mean, it's in the hash graph. It's in the event that's recorded in the hash graph of the timestamps, and then we come to what's called a consensus timestamp. When did I learn it?
When did you learn it? When did you know what you knew, where you knew it? So that actually made me stop and think for a moment when I saw this video that kind of helped to describe the process. One thing that jumped in my mind was, okay, if I were an evildoer and I wanted to jump in here and cast a vote, or I wanted to change the vote and completely wreck the process and try to steal the transaction, maybe somebody else's, data or coins or whatever they're putting up there, how does this prevent that? I mean, I can easily disguise who I am online, right?
So yes and no. So, and this comes into, you could possibly convince a couple people that you talk to, or a couple devices that you talk to, that something false is actually true.
Okay.
It's the old, you can fool some of the people some of the time, but you can't fool all the people all the time.
And why is that important? If I got half the people to agree with me, why wouldn't I win the vote?
And that's why it's a 2/3
majority. Gotcha.
And in all cryptographic, whether it's cryptocurrencies or distributed ledgers or what have you.
Even NFTs, they have a similar process of verifying the data, where they were put online and when and how and so forth.
Exactly. And we talked about timestamps, who knew it, when they knew it, and this gets into the double spend problem. If I can put two different timestamps on a thing, and spend the same thing in two different places, can I, or to use the stock example, if I see you issue a purchase on a stock, can I front run your trade and by putting an earlier timestamp on it so that I buy it before you did, and then I can sell it to you in milliseconds of time? Well, it doesn't matter what any one device says the timestamp is, because we take what's called a consensus timestamp. It's, I know when you knew it, I know when everybody knew it, I knew the timestamps that they put on it, and we're going to take a consensus timestamp, which is the mean of all of the timestamps. All
right, so virtually unhackable in the way that we're designing not just the timestamps and the votes for the other members of the nodes, but the process itself is also voted on and authenticated on 2/3 majority. And even though I'm an evildoer and I may put on a mask and decide to disguise myself, there is no way I'm going to affect or modify the ledger, the vote, or the process, right?
Yeah, it's that you cannot fool all the people all the time.
All right, but that's exactly what happened on the blockchain when people have lost money and they've had other things that were, basically defrauded because they were able to modify the ledger in even microseconds, like you pointed out. That's enough time to insert something that doesn't belong there. Even when the blockchain comes back and tries to recorrect the ledger, the damage is done. There's no way to recover that. Is there a similar flaw in the Hashgraph network?
So because it operates completely differently than just a blockchain, it's kind of, there's no direct analogy between the two.
Good. That puts me at ease, actually. Yeah.
So, and you and I have talked about before that Hedera has even put on hackathons where they invite hackers to please hack us. Do your best.
Prove me wrong. Yeah, but more importantly, test the security.
Exactly. And and if there are flaws, let's find it. And this has been going on for years. Hedera is, I believe, 7 years old. I think.
Yeah, I think somewhere in there now. Right.
I could be wrong about that, but I mean they've been doing this for years, and it's the whole, implement a new feature, test it, beta test it.
So Troy, I hate to interrupt, but I want to kind of wrap things up here. I know your time is valuable, and I really appreciate it. That being said, I have one more question about blockchain versus Hashgraph. Right now, in the state of the internet as it is, can we do almost everything that we've been doing on blockchain on a Hashgraph network?
And then some.
Wow. Okay.
So and that's one of the reasons I talked about the things that get stored in Hashgraph or events. And those events could be anything. They could be a transaction. They could be an NFT, so on and so forth.
So, basically creating NFTs and all the expense that goes with that, and buying and paying for the fees and the gas and yada, yada, that can be done much cheaper on Hashgraph right now.
Yeah. There's no comparison. It's as far as expense goes, speed, versatility, security even. I mean,
we're talking about, okay.
Exactly. And I could talk for another half hour about that.
I would love that. I actually would enjoy doing that with you. We'll save that for another time, obviously. Exactly. But, the way that this has come about is I don't think we have any balance here as to which one or the other is the winner. It's clearly Hashgraph has pulled it out here by a long shot as a much better ledger network that allows us more utility. So, let's kind of schedule a future date and talk more about that, because there's just a lot of things that pop into my head about places that we could use this, applications that we could run, things that we could verify, and how that'll all come together. Troy, thank you very much for the interview and your time. I appreciate it.
No problem.
So we're going to come back here and wrap up the show. I want to thank everybody for watching this interview with Troy. We learned a lot of cool things today about ledger technologies, blockchain, and Hashgraph. So we'll see you next time. Thanks again.
The internet is not something that you just dump something on. It's a series of tubes.